Assalamualaikum warahmatullahi wabarakatuh, and salam sejahtera to everyone. Okay, let's continue the next video for this chapter, valence bond theory. So in this video, we will talking about the overlapping of atomic orbitals in single and multiple bonds. So what we should in this subsection we try to identify two types of bonding, which is sigma and also pi. Sigma bond and pi bond. For single bonding, it has one sigma. Hold on. Yeah, one sigma. And then for the one sigma, for the double bonding, it has one sigma and also one pi. For the triple bonding, one of them is sigma, the two another bonds pi. So in triple bonds, one sigma, two pi. So in whatever molecule given to you, you should be able to identify sigma in pi, and you should be able to tell how many sigma bonds, how many pi bonds. It's a very simple. Single, double, or triple all has sigma. The pi bonding only for the double in triple. For example, in this bonding, double bonds, one sigma, one pi. For this double bond, one sigma, one pi. If you ask to count how many sigma, how many pi, you have to count every single bonds. Let's say this is another example. It containing of a single bonding, double bonding, and also triple bonds. As you can see, for those single bonds, it is a sigma. For those double bond, it contains one sigma, one pi. For the triple bonds, one sigma and also two pi's. So we try to understand what is a sigma bond, what is a pi bond. Sigma bond, it should be can be formed using end-to-end overlapping. As we covered in the previous video, if we have s orbital overlap each other. For example, this is the hydrogen molecule. One s overlap one s, end to end, it becomes sigma. This one is a sigma because hydrogen single bonding. Another overlapping also can be from px and px. If you still remember x, y, and z. So the px, py, pz like this. This is a px. This is a py. This is a pz. So the orientation in x-axis, y-axis, and also z-axis. For the sigma bonds, for the p orbital, it should be px with px. The example of molecule have this px overlappings is like Cl2. p orbital of chlorine overlap with p orbital of another chlorine. And yeah, this is a sigma Cl plus Cl with Cl. Another example, it can be from S overlap with Px. S overlap with Px. Example of molecule like hydrogen chloride. Okay, hydrogen chloride. Hydrogen is s orbital, the valence electron s orbital, the chlorine valence electron is p orbitals, px orbital. So this is the Lewis structure of the HCl. So this is a sigma because of single bonding. This is sigma, and also this is sigma. All right. So now we're moving forward to the pi bond. As I said to you, pi bond it should be between py or it should be between pz and pz. So it's side by side. Py is like this, side by side, and also pz also can be side by side to produce pi bonding. Pz with pz. Okay, in this orientation. So this is the example of overlapping between side by side to form a pi. Okay, so this one is a pi bond. Either you want to draw like this, or you want to draw like that, or you want also can do like this. It's depending which one that you think is the easier way to draw the pi bonding to show the overlapping of side by side. So okay, this same is another presentation. Py py to form a pi bonding. Why pi? Because of side by side overlapping. Py or also pz. Px we consider it end to end, so it's mean that it's a sigma. So the pi bonding, as I told you before, either in a double bonds or triple bonds. This one, it should be py with py. This one, py with py, and also pz with pz for the triple bonds. Only p orbital, double or triple bonds involved in pi formation side by side. Okay, we go a few example. We try to identify how many sigma, how many pi, where you can obtain sigma, where you can obtain pi. And also we try to integrate with the hybridization. We try to identify for whatever molecule, what is the hybridization for the central atom, and then we try to identify how many sigma and also how many pi. So the first example is ethane C2H6. So if we have this molecule, we can tell the hybridization for this carbon. As you can see, this carbon, it has four electron pair, 1, 2, 3, 4. and also 0 pair. So the electron domains is 4 plus 0 is considered 4 electron domain. 4 electron domain is the sp3. Same goes to another carbon, it also sp3. In terms of sigma or pi, as we can see, all the bonding in this molecule are single bonds, so it means that it's sigma. How many sigma? You just count 1, 2, 3, 4, 5, 6, 7. 7 sigma bond. All right. This diagram is further explain about the overlapping. I think you already covered in the previous video. For this carbon and carbon, between carbon this carbon, between carbon this one is the overlapping of sp3, sp3, this one, sp3, sp3. So the electron domain, the region have electron is the overlapping area. We label it as a sigma bonding, sigma bond because of single bonds. Another overlapping should be between the sp3 of carbon with s orbital of hydrogen, like this. Between carbon sp3, hydrogen it should be s. The bonding between the sp3 carbon overlap with s of the orbital, it should be sigma. Okay, so all this one sigma, 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 sama je macamnya ini. Alright, okay. So the both carbon are sp3 hybridized, as we did before, how to identify the hybridization. Between carbon and carbon is the overlapping of sp3 with sp3 to form sigma. Between the carbon and hydrogen is the s with sp3 to form sigma. All single bonds are sigma bonds. Okay, go to this another example, ethylene. We know the double bonding, 1 sigma, 1 pi, the single bond, 1 sigma, sorry, the single bond also sigma bond. So you can count how many sigma, how many pi. So sigma 1, 2, 3, 4, 5. How many pi in this molecule is 1. So from this Lewis structure, you can show to the hybridization using the valence bond theory to show the overlapping of atomic orbital. Or like this. Okay. But this one maybe is a bit complicated, but just do as you learned before, carbon, and then this one we know sp2 overlap with sp2. Why sp2? Because of this 1, 2, 3, 3 plus 0. It should be electron domain of 3. So electron domain of 3 is sp2, and also trigonal planar. So this one is sp2 with sp2. And then it is a sigma. Okay. So sigma. About pi, you can draw the pi component, this one, px, sorry, the pi it should be py because it's pi. Okay, the px is sigma, py is also to form pi mono. So this one is pi. Okay. So another atomic orbital is between this one with the it should be trigonal planar like this. Should be yeah, kurang lebih macam tu lah. And then every this one overlap with the hydrogen, 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 like this. Okay, like this, like this, like this, like this. Okay, so the sigma bond between the carbon and carbon is the overlapping of sp2 and sp2, and the overlapping of the py and also py to form pi bond. So you can write it, you can draw it like this, or also like this, or also like this. Okay, all right. So this is another important fact that you have to understand. The half-filled unhybridized 2p orbital of carbon are close enough to form side by side or pi bond. So this means that to form the pi, the orbital it should be unhybridized and is half filled, only one electron. I think we have example of it. Do we have? No, we don't have. So maybe we can try to show how the valence bond theory show the formation of pi. Because the pi component side by side, it should be half filled and hybridized. So we can try one of the carbon, this one, C prime. Because this C prime, we have sigma in pi. So how to draw? How to draw? Okay, kita buat dekat sini. This is the C double bond C, and then they have hydrogen, hydrogen. Hydrogen, hydrogen. We want to show how the valence bond theory for the pi, because we know the pi it should be unhybridized 2p orbital. So we know carbon from the periodic table, it should be 6 electron. So it's 1 S2, 2 S2, and also 2 P2. So the valence electrons is, sorry, This one is not 4. This one is 2. So the valence electron is 4 valence electron. And then we know each carbon in this particular example, it should be what type of hybridization is the sp2. Same goes this carbon sp2. Why sp2? Because 3 electron domain, 3 bonding pair plus 0 lone pair. So if you want to draw the energy diagram of carbon, so we know in order to draw the energy diagram of carbon, we must have energy excess, part C, energy. And for the carbon, we know the valence electron is 4 valence electron, 2 s2, and also 2 p2. So 2 s2, 2 electron, and we have another p orbital, which is 2 p2, 1, 2. And then these 2 single electrons is not enough to form 3 sigma, one with this hydrogen, one with this hydrogen, another one with this carbon. So we already decide it should undergo sp2. So we hybridize to form sp2. So now we don't have any lone pair, so it's meant that this electron should be moved. This electron should be moved. Okay, because we don't have any lone pair, so we need 3 single electrons. So what hybridization that we're looking forward? sp3. sp3 is meant that 3 boxes. One electron from the S, this one electron from the P, that one electron from the P. So the third P electron here is not involved in the hybridization, but it is unhybridized with 1 electron. So this unhybridized half field will form pi. This one will form sigma, this one will form sigma, this one will form sigma. Sigma with hydrogen, sigma with hydrogen, sigma with the next carbon. Okay, so remember the pi bonding side by side is the electrons from the half field unhybridized orbital. So in this case is this one unhybridized orbital. So it means that if we have triple like this, so it should have two unhybridized orbital. It should have 2 unhybridized orbital. Okay, so this one is the py with py, or we can draw like this. Okay, we go another example. Acetylene. How many sigma? 1, 2, 3. How many pi? 2 pi, because it's triple bonding. So what is the hybridization? Electron domain of 1 and electron domain 1 plus, 1, 2, 2 plus 0. So electron domain of sp. So we know this carbon with this carbon is formed between the formation of sp overlap with sp overlap with sp. And then this hydrogen is the sp overlap with s. So this one is the sp overlap with sp, and in each carbon with hydrogen, carbon with hydrogen is between s with sp. So you can draw like this, or you can draw like this. Again and again, because it has a pi component, pi bonding, it should be half filled and hybridized orbital. Okay. So how to show the energy diagram? Seems that we did here. The unhybridized of carbon orbital involved in the formation of pi component. Okay, let's say we want to draw the molecular atomic orbital of this molecule. C, 1, 2, 3, C, hydrogen. We know this carbon central atom is sp. sp and also sp. We try to observe the formation of pi. Because of this carbon, carbon is of 6 total electrons, so electronic configuration is 1s2, 2s2, and also 2p2. So the valence electron is 4 valence electrons. If you want to draw the energy level to show the formation of hybridization, this is the E energy. So for the carbon, we know carbon is 2s2, and another 2p2. P2, 2p2. So this carbon will undergo hybridization of sp in order to form with the hydrogen, or with the carbon with carbon, it should undergo sp. So sp, we have two boxes. So because we don't have lone pair, one of the electrons should be moved. So because of this carbon is a sp, so we have two boxes, one electron, second electron. So another two orbital, which is this and this, is unhybridized. We have two electron unhybridized. 1, 2. The sp is 1sp, 1s, sorry, s and p to form the hybridization. Another two, this one and this one is unhybridized. So this one will form the first pi, and this one also form another pi. This is why we keep tell the half-filled unhybridized form the side by side or the pi bond. Okay. So I think enough for this video. This video is talking about the sigma and pi. We just recap. In this subsection, we try to understand the formation of sigma. In pi, we know single is 1 sigma, double is 1 sigma, 1 pi, triple 1 sigma, 2 pi. Okay, so in variable molecule, you should be able to count how many sigma and also how many pi. So this one is show the formation of sigma is n to n. So we have several combination of atomic orbital, either SS orbital or a px orbital or s with px orbital. So all these three is overlapping of different orbital form a sigma, sigma, and also sigma. So the next one, we discuss about the pi bond. Pi bond, it should be side by side. As I told you, pi, it should be py, py, or pz, pz, py, py, or also pz, pz. So you can draw using the dotted line, or if you can overlap it, you overlap it. You can draw like this, or you can draw like this, ataupun you just draw like this using the dotted line. Okay. So only the p orbital involved in the pi component. So in this molecule, we should identify how many sigma, and then how the hybridization can be formed, how the hybrid orbital can be overlapped to form this molecule. Okay. So you should be able to discuss the overlapping sp3 with sp3, sp3 with the s orbital to form a sigma. All right. All sigma bonds are, all the single bond are sigma bond. So goes to another example. It involve double bonding. Is we know the double bonds are 1 sigma and also 1 pi. So you should be able to count how many sigma, how many pi, and then what is the hybridization involved, and then you try to explain the valence bond theory. It's between what orbital to overlap with what orbital. Okay? All right. Last but not least, remember about this statement. The pi component, it should be unhybridized to p orbital, which is half-filled. So I explain it the energy level diagram. I show it how the unhybridized form the pi component. So for this molecule, it has 1 sigma. Sorry, it has single and also triple bonds. So in total, 3 sigma and 2 pi. Okay, the diagram is look like similar. And I also explain to you how the pi component can be formed. Remember again and again and again and again, the pi component py, py, or pz, pz is unhybridized. The hybridized part is to form the sigma bonding between the sigma, between the single, the sigma in the single bond, or the sigma in the pi, or sigma in the triple bonding. All right. So I think it's enough for this third video. The next video will talking about the delocalized pi electron. Just now, we identify which one is sigma, which one is pi. So in this subsection, we try to describe a little bit the delocalized pi electron. So I think we stop here. I will prepare another video special for this delocalized pi electron. By Sitso, thank you very much. See you again in the fourth video.